and then we'll go from there. I think it's 27 is the one I need, and then that's probably all we need. This is weird. Oh, actually, I think we made one. We made something for this before. So, okay, so I got a new keyboard, so I'm gonna have to get used to it a little bit. But we should be okay. Okay. And we're probably gonna need some language extensions, but I don't know what yet. Oh yes, I do. Flexible instances. Functional dependencies, which I've never used before. Multi-param type classes. Type families. Oops. And undecidable instances. Okay. So I think those are the things we need. Thought it was. Okay, that's right. There must not be. Thought it would format this stuff, but apparently not. So hello, random viewer. How are you? Oops. Okay. All right. So until recently, so the last time we talked about associated type families, which were pretty cool, but to be fair, we haven't worked on thinking with types in a while. So it's probably gonna take me a little bit to like get back into this. Hopefully we can figure this out. So I noticed 2 people are watching, so hello. I will mention that we got some followers while I was gone. Meet Amin 7 and Barano both followed. So we've been doing pretty good with the followers. I think we're up to 66 of 75 for our next sort of goal, I guess. So anyway, until recently it was believed that type families had no chance of being first class because they are unable to be partially applied. Reuse and abstraction seemed impossible goals. Every type level F-map would need to be specialized with its mapping function built in. There seemed no way of abstracting this repetitive boilerplate. The work of Li Yao Jia, my pronunciation is probably not correct, but that's my best I can do, has relaxed, not by providing unsaturated type families, but giving us tools for working around them. It works via defunctionalization. Oh, you know what? I need to change some stuff. I forgot about a few things. So, whoops. So chapter 10 is first class families. Okay. So, reminder, here's the function first. Why? I'm not using any of the other language pragmas. Why is it complaining about that singular one? It's kind of weird. Um, okay, so here's first, just as a reminder. Oh, you know what? This is probably unreadable. Probably better. Hopefully that's readable now. Sorry. We can instead defunctionalize it by providing an equivalent label. Okay. All that's left to implement is the actual evaluation function. This can be codified as a type class with a functional dependency to guide the return type. What is this complaining about? Yeah, that's what I... Wait, how can we use a new type? Okay, so it doesn't actually do it. No way, that's the proper format. Gotta be like that. Okay. It tells us to use a new type, so let's see if we can do it with a new type and not just data. Okay, so this syntax is new, which we have never seen before. I have not seen that before. Maybe someone has, but I have not. This is known as a functional dependency, which is, I guess, what that language extension is doing. And states that the type T is fully determined by the type L. Okay, so if we know L, we can get T, I guess. Here, L is the type of our defunctionalized label, and T is the return type of the evaluation. Oops. Okay. So T, which is this A, is fully determined by L, which is true. Okay. So this return type is dependent on this. Okay, I can deal with that. Despite being roundabout, this approach works as well as first itself does. So we should try this real quick, I guess. Howdy viewers, I see a few people just joined. How's it going? Hope your day is well, going well. We're trying to learn about first class families and functional dependencies in Haskell. Tonight is our thinking with types night, so oops. Oh, duh. Sorry. It's gotta be it. There you go. it's got to be the a tuple. Okay, so now we're gonna try the same thing with another function. Okay, so we got I guess this function is just this. I think that's right. Okay, so we're gonna defunctionalize this. Okay. So defunctionalize. So we need let's see if I can do this. So no. Sorry, new keyboard. It's gonna take me a little bit to get used to. Okay, so basically all we did was make some new type that contains the left side of the equation, and then we need to create an evaluation so eval was to maybe a, we want I think this. Oh, except this doesn't make any sense. I think that's right. Let me just look at the answer. Oh, I should put the exercise here. Defunctionalize list to maybe. So, okay. let's put some notes in here. So syntax T is fully determined by. I really like this keyboard thus far. Okay, and then let's go check the answer, but I think that looks right. So we're 10, chapter 10. Oh, shoot. Okay, so technically this is basically list to maybe is a head function. So but generally speaking this is correct. But that's fine. Okay. So even higher order functions can be defunctionalized. So oops. So map list okay. Uh, eval map list. D why D DFB. I don't know what this type is supposed to be. I guess we'll see here in a second. Okay, so let's see here. So the DFT is fully determined by DFB. Okay, I think I'm okay with this. So yeah, this is fine. Yeah, so this excuse me. That's what this is for. This fx is for this piece. So this eval has the type eval dfb dft, and then this is just recursively calling itself. Okay, yeah, I'm okay with this. Neat. So pay attention to here. Rather than consing fa to the mapped list, we instead cons eval fa. While there is morally no difference, such an approach allows defunctionalization of map to propagate evaluation of other defunctionalized symbols. We can see it in action. Let me show this so we can see it quickly. Eval map list. On oh, I see. Okay, so we're mapping first, which is an eval type, onto a list of things. That's pretty cool. How cool is that? Okay, let me read that code again. So F is this thing. So as long as it has eval, you can use it. That's cool. Okay, so we need some more stuff here. Data kinds, signatures, poly kinds, type families. I already have that one. Type in type. Do undecidable. I already have that one. Okay. Then we need data kind constraint. Okay. So type level defunctionalization. This entire line of reasoning, as Gia shows, to the type level where it fits a little more naturally. Because type families are capable of discriminating on types, we can write a defunctionalized symbol whose type corresponds to the desired type level function. These are known as first-class families, or FCFs for short. We begin with a type synonym, exp which describes a type level function. When evaluated, will produce a type of kind A. Here, let me put some space here. Okay. This evaluation is performed via an open type family eval. Eval matches on exp A's, mapping them to an A. Oops. To write defunctionalized labels, empty data types can be used. As an illustration, if we wanted to lift second to the type level, we write a data type whose kind mirrors the type of second. Oh, maybe we should do this in another file. That's not what I wanted to do. F. I guess so. I guess we'll work in here for now. So spaces there, spaces there. This looks fine. Okay. So now we got this. I don't remember doing too much with this, so I'm gonna have to read this very carefully. Okay. Um, we're gonna leave this open for a little bit, I guess. Okay, so basically you're mirroring the kind for second as the type, but you have this extra type at the end. So an instance of eval can be used to implement the evaluation of second. I guess I don't really need this open. Okay. So instance eval. Type instance eval. Promoted data constructor for tuple equals B. Okay. Again, I haven't played too much with this stuff, so we're gonna have to. I mean, this is the kind of stuff I need practice with at some point. But the fact that we're writing it once is a big deal because we can practice later, I suppose. So functions that perform pattern matching can be lifted to the defunctionalized style by providing multiple type instances for eval. So as an example, Interesting. That's cool. Okay, so can this just be this? Okay, that's good. Not really sure. So the only reason I wrote the one is because the author wrote the one, but I'm not sure that that adds any more information. That's interesting. Right, this just means like ignore this. If we get a just use this A. And these are the promoted uh these are the promoted type data no. Yes, data constructors. They have to be data constructors. They can't be type constructors because it's just a nothing. All right, interesting. So defunctionalize list to maybe at the type level. So we'll use the same we'll use the same definition we did here, although technically it's not the correct one. So first things first, we need uh wrong with this? Oh, anything else? Conflicting family. Maybe they're supposed to be I didn't think that was gonna matter, but I'm mostly just curious. Hmm. Not really sure what's going on here, so we're gonna quickly open up our trusty GHCID stack. See if this says anything more useful. Conflicting family instance declaration. not really sure. What's up, typed rat? How's it going? Thank you for the follow. I just noticed that. How are things? I'm guessing with a name like typed rat, you like type level programming, or hopefully Haskell at least. Okay. I think I see how. Okay. Because of the way I'm doing this, I have to do this differently. So oh, oh, wonderful. What are you working on? In Haskell? Oh, duh. Code to pick up our generic reps. I'm not done enough of that, I suppose. I don't really know what that means. Why is this? Why is this an illegal operator? My cat is meowing very loudly. I don't know if you can hear that. I'm a little confused. Can I not? Oops, that's not what I wanted to do. Can I not write this? I'm really confused right now. I'm a fan of types and cats. Well, you are in the right place because, well, for Sundays anyway. I do type level stuff on Sunday. Type instance eval. List to maybe. A. I don't think it should matter if I put this here. Legal operator. Oh, it says literally use type operators. I'm a doofus. It's right here. So dumb. My bad. My bad. I'm hoping that someday I'll be able to like actually write code like this. Yeah. Yeah. It's pretty hard sometimes. I mean this stuff is pretty tricky for me. So I should be able to do that, and then I should be able to write this, and everything should be good. I think. Conflicting. This is the same error I had before, though. So I can't write this. I have to write. Okay. Okay, okay. So you can't you can't just put an anything here, apparently, for whatever reason. So this is what I, just for reference, this is what I'm writing. This is what I wrote before for list to maybe. It's not, so in his code, he writes list to maybe as basically head, but I'm writing not as head as, wait, no, this doesn't work. I have to write it as, because this will fail for this case as well. So anyway, we'll write the code that we want to write. So basically anything cons anything cons anything is also nothing. Wait, I don't even need this many things, right? Or will this conflict? Yeah, yeah. That's interesting. Okay, so anyway, but this works, right? Because this would be a list with 2 things in it, so this is fine. Or, well, actually, this is a list with anything in it. So I think this works. Or is this literally 3 things? I'm trying to look at, I want to look at this implementation to think about it a little bit more. Yeah, so I think this is fine. We can test it real quick. Shouldn't be a big deal. But we'll put this under here because it'll be hard to see otherwise. So eval list. Okay, so it works as expected, so that's fine. Anyway, this was the function we were writing, so this is the function I'm going to stick with. And anyway, I think that's the correct implementation for this particular function. In the book, it's implemented as just head. I don't know if that comes from something. Maybe. Oh, no, hang on. I assume there's a list to maybe function that already exists, and I'm going to guess that it is implemented as head. Well, okay, it's not it's not implemented as exactly head, but I think this works out to the same thing. Yes, I'm pretty sure. It's a non-partial head with a worse name. I like it. Okay. So anyway, it's implemented this way apparently for string fusion, or just string list fusion. But okay. So cool, we did it. We did a thing. But this is how I implemented it. So this is how we're gonna continue implementing it. Yeah, that's a spicy implementation right there. Someone very clever, I'm sure, came up with that. Okay, so the real appeal of this approach is that it allows for higher order functions. For example, map is lifted by taking a defunctionalization label of kind A toXt B and applying it to a list A to get an X list B. Okay, we'll start writing that. So data map list. Can you hear my keyboard, by the way? I want to know if it's too loud. I just got a mechanical keyboard for the first time, so I think it's very loud, but I'm not sure if it's actually getting through the noise gate or not. It's not super obvious to me. Okay, if it feels really loud, just let me know. These are browns, so I was gonna get blues, but somebody said the browns are a little bit quieter, so I went with the browns instead. But they feel really nice. I mean, this is the first time I've ever had a mechanical keyboard. It's a, well, here, I can just show it on the screen real quick. It doesn't quite reach here, but it's a Vortex something or another. I forget its name. I have to look it up. I have it like strapped down pretty nicely. But it's a Vortex and it's pretty small, so I'm trying to get used to the keys. Yeah, it's nice so far. I mean, I just started typing on it. I got to get used to the layout a little bit because it's, you know, it's a pretty compact keyboard, but you know, it's heavy. It feels really nice. I'm pretty happy with it thus far. But I've never had one, so now I have a feeling that I'm going to get to work tomorrow and be like, "Wow, my keyboard sucks. I really want to get a mechanical one at work." Let me make sure I write this because I'm talking and typing at the same time. That's always a recipe for disaster. AXB, AXB. Perfect. So type instance eval map list empty list. Okay, so are these supposed to be these constructors? Why is his cat freaking out? That's weird. So it takes both of them. Is that logical to me? Oh, I remember what this is called. It's called a race 3. That's what it's called. Here, we can look it up real quick. Vortex race 3. Yeah, that one. Right there. I got it on mechanicalkeyboards.com, but it took forever to get here. So but it was a ton cheaper. So if you're in the market, I guess. I have a feeling we're gonna have to do some type level trickery for this, but maybe not. Well, we sort of did this before. Huh? Oh. So this, that. Well, that's cool. Where do you get you get like custom keys for it? Oh, but it's the same keyboard more or less. Ish. It's a little wider, I guess. Is this like a gap here? Can I rotate this? I have no idea how to do that. There's probably a way to do that. That's really cool though. I like your keys a lot. Pimp my keyboard. All right. I'll have to check that out. That's really cool. Just to get, you know, I like this flower down here, for example. Like that's super cool. I have no idea why it's sideways. That's just how it opened up. I don't even know how to rotate it. There's probably a way to rotate it. I don't know how to do it. Anyway, cool. I like the colors too. Really nice. Okay. Let's see. Man, that's really cool. Except it looks like there's probably an error. Oh, I'm missing a parenthesis. There we go. That's really neat. So we have a type level map list. It's the white fox. Oh, is that what? I'm sorry. So the pimp my keyboard thing is. I don't know what white fox means here. Let me. No. Can I search on here? Oh, I see. That's what the keyboard is called, the white fox. I got you. Yeah, I could see myself investing in. Like, this looks so cool to me. Like, I really like this color scheme a lot. It has no. It's just perfectly ugly, right? Like, it's perfectly ugly. I could see myself getting really into this. Hopefully, I don't because I don't want to spend a ton of money on it. But I could see that happening. It's really cool though. I like that keyboard. Again, I'm just getting used to this one, so the layout's a little new, and I'm not used to the fact that it's, I've always used it raised, like slightly raised just a little bit, and so it being perfectly flat is interesting. I'll have to get used to that, but I'm sure it will come. Oh boy. Okay, so now we need. Oh, I should write these as exercises. My bad. So this was exercise 10.2 dash I. So okay, so folder is gonna take an A, a B, and probably produce this. It's gonna take a B, a list of A, and make an XB. Guessing. So eval folder F B empty list is B. I'm going to use the terminology that I prefer. Um, that right? Interesting. Okay, so yeah, if you catch an empty list, just return the accumulator. This here gets you the new accumulator, and then you just continue evaluating your fold until you hit empty list. I think it's right. Oops. Let's see. 10.2 II. Oh, this is fold left though, isn't it? Yeah. Right. This is fold left. This is not fold right. I will always forget how to do that correctly the first time, but that's okay. So what we actually need to do is do this, and then ugh, why am I being dumb? Yeah, this can't go here. Oh. Okay, need to think about this. Let's draw a picture because I'm feeling really dumb right now. Um, right. So, whoa, no, that's terrible. It's probably terrible as well. Yeah, that's so we have. Oh gosh. Okay, that's fine. So you have the tail of list, then you have, you know, uh, delete that one. So we got Atlas. I'm not left-handed though. Hang on. A, B, C, D. Right, bad D. It's pretty hard the way I'm doing it, but that's fine. Sorry for the terrible writing. and then this one. So our accumulator goes here. The problem is I use my mouse with my left hand to try and not destroy my wrist all the times. So that's kind of what I'm doing. Okay, so here's the worst picture of fold right that's ever been created. However, it gives you the idea of what's going on here. So basically, you're inserting. Oh, you need to insert F here. Yeah, and basically take FAAC. So that's the idea. So that's hilarious. That's probably a good way to do it though. With LaTeX, it makes your math a lot more readable. Although I don't know how to draw this really quickly in LaTeX. Now, one idea would be to get like a pen and paper kind of setup so I can actually draw better. But that might be a little like that would be pretty expensive to do. So let's not worry about that too much. So this is what we need to do. Can you still see this if I put this here? Sort of. I just need to move it up a little bit. DW. Okay, good. So let's put that there. And then we'll put this here and we'll sort of just go. So the first thing I need to do is apply F to A and AC. No, that's the last thing I need to do. But that would look like eval F A C. And that would give me what I want. Oh, except this is really backwards. This is an A. Sorry. Hang on. Are these connected? Shh. Nope, nope. There you go. Okay. That's a better representation of what we need to do. This is already incorrect. So this is where fold R F and then we just need to combine this with the A. So F of this whole thing and A. Like so. A goes last. I think. So this, yeah, this would evaluate F of DAC first. So I think this is right. It might have weird parentheses or something, but I think it's correct. The good news is I have the answers this time, so I can make sure and look at the right answer and think about it. Hmm. Okay. I'm a little confused, so let me write this and let's think about it for a second. So, um, nope. Nope. Give me a second. There you go. Oh, yeah, yeah. Sorry, the accumulator's on the right. This is not correct. Why does this compile? This A... That shouldn't compile, right? The accumulator has to approach on the right, so I just had this backwards. But why did this work? Um, why does this even compile? I'm not sure. This gives you a B. I'm confused. What if I try and build it? Does it fail? It does fail. But we don't see that fail. Oh. Where are the mismatching parentheses? Ah, there they are. Okay. So this would have failed, but I couldn't see it. So wait, why is there no... That's interesting. Oh, it's up here. Okay. That's fine. I think we might have found it if I tried to build and realized what we were doing, but not 100% sure of that. I'd like to think that I could have found that, but that's kind of tricky because the error isn't where you're typing, it's at the top. I gotta remember that. I love that automatic formatting. So great. Okay. Okay. Yes, this makes sense. So actually what we implemented before was fold F. Sorry, fold L, not fold R. I think. It was approximately fold L anyway. The first time. Okay, so working with first class families. Interestingly, first class families form a monad at the type level. Of course they do. Um, so hmm? Oh, it was? Okay. Thank you. That's useful information. I always do that because it's the more obvious way to, like, fold L is the more obvious of the folds to me anyway. Um, I think when I think of folding, I always think of doing F, A accumulator or whatever, even though technically that's not really the right way because the accumulator literally has to approach from the right for it to be fold R. That might just be a good thing to add to our little quiz thing that we're working on, just to practice. I forget where I put that, but we'll create an issue for that because I do want to work on this eventually. Uh, what is it called though? Type rodeo. So the idea of this is to take some things that we had trouble with and then just work on them more often. So yeah, yeah, I like these pictures a lot because this is how I picture uh fold. When I want to do a fold, this is what my brain sees. This is not what my brain sees, but this is a good way to think about it. I like these pictures. Cool. All right. Yeah, we'll put that in there as an issue. We'll fix it later. It's not that important, but I think that fold is probably a good example of something to just think about. It helps you think about like the structure quite a bit. All right. Anyway, a no. Oh yes. Sorry. You know what I just noticed? Typed red. Did that show up? Did that notification show up for you up there? I just realized I don't think that I saw it. But Blue Laguna, thank you for following. I really appreciate that. I don't remember seeing it now that I saw that one. But maybe I was like looking away or looking down or something. Okay, fair enough. It may not have shown up. It just helps me, you know, keep track of people following and stuff. So, Blue Laguna, if you want to tell us what you like to do, let us know. If you like Haskell, you're writing Haskell, let us know. Appreciate it. E. Okay. Uh, So we unwrap E and then apply K to it. That's really funny. Blue Laguna, I am also a sloth. It took a, well, I don't know, maybe this is fast, but in the last, like, we started doing Haskell programming from first principles at the beginning of the year. So that was my New Year's resolution, was to get through at least Haskell programming from first principles. So we did that basically from the beginning of the year, but I was already partway through the book. So it's hard. It's really hard. But you're welcome to come hang out and try and learn some stuff if you want. So this is all type level stuff. So what are you using to try and learn Haskell? Out of curiosity. I'm a hardcore believer in textbooks. Well, thank you, Typed Rat. That's appreciated. I think I almost have the right mind for this stuff. Like, I'm getting to the point where I'm getting close. Like, this kind of stuff still is hard for me. The NICTA course. I've heard of the NICTA course, but I've not done that myself. I think that's on my list of things to do. Let me double check actually. Where is that one? Also GitHub somewhere. I think it's this one. Oh, I have the data here. I can give you this, by the way. If you're interested in looking through this, that's not this. This is what I'm using to learn myself. Don't use this as a great reference, but if you're interested in looking at this, that's all. The two courses that we were going to do are these ones. But there's a lot of stuff on this list of things that we want to learn about. But right now we're doing books. So we're doing this book, and I just realized that we don't have this other book. Oh, that's okay. I didn't realize that. But that, yeah, we have that on the list. I just realized I didn't add something to this as well. So we are also doing Book of Monads. So we do that on, I think we do that on Tuesdays. Yeah, so we do Book of Monads on Tuesdays. I think that's what we decided. Tuesdays or Thursdays. And then I think it's Tuesdays. And then on Thursdays, we basically go through and do things from, gosh, what is that thing called? Exorcism. So we do this exorcism thing. So they also have Haskell stuff there. It's pretty nice, actually. It gets you thinking about monads and things. Like some of the first whatever exercises we did there actually required traverse. So like you get into it pretty quickly. Some of them are easier, but anyway, it's kind of interesting if you're interested in other sources to learn. Okay, so we compose the monads in terms of their Kleisli composition. You can't use dot at the type level because it conflicts with does it? It might be incorrect. Yeah, that's actually a good point. That's not supposed to be B, that's supposed to be A. Maybe there was an error? Hang on. Let's see if it actually builds. It seems to build. I'm not sure. Maybe it's just because maybe it's because this B can be A. You're not forcing it to be something different. I don't know, something like this. Or do you mean that you were expecting like something here, like a type constructor in this location? Yeah, you're right. Trademark. Yeah, no, you're right. That was technically the incorrect type description. I'm not sure why it didn't fail though. It's not super obvious to me. Well, okay. Um, should that fail? I'm trying to think. So if we had a function and then we just take f of x equals x. Okay, so it does fail. It does fail here, but apparently in these are called open type families. Is that right? I think it's open type families. That's correct. Okay. Yeah. So in the open type family, apparently you can get around that. Or apparently it's not strict. It seems like it's almost a bug, but I'm not sure if it is or not. I don't know enough to be like, yeah, that's a bug. It seems like if it was a bug, somebody would have already mentioned it. I'm not sure. But that's interesting. I'm glad you noticed that, because that was not right. That's because pure does still have the A. It just has a bonus phantom B that doesn't matter. But doesn't this over here have to be the right type? Okay, I can do that. Yeah, it seems like it breaks when you try and use it. Let's see if this works. Because it can't satisfy... No, this fails too. Maybe I should do like... No, something... I'm doing something incorrect. I don't understand. I'm very confused. Oh, yes, that's true. I'm super confused right now. I'm not sure that this matters, but I'm kind of curious now. Do I just need... I mean, let's just try this. Hang on. I just want to make sure this like, if this just fixes the problem. It does not. Hang on. uh, uh, right. Um, need this, and that. I'm trying to find like an example here. So pure. Okay, so that works. Okay, we're getting somewhere. So if I use where'd it go? So you, oh, nice. Okay. So what's this bang here? What's this for? Sorry. Just got done reading your bio, and your academic career sounds really interesting. Studied chemical engineering and chemistry, two BS degrees. Yeah. PhD is really, I mean, it's hard, very hard, time consuming. It takes you at least 5 years to get one, but if it's really what you're motivated to do, then you should do it. That tells it to evaluate the type family. Is that coming from one of these extensions? Okay. So do I get that? Like if I just do this and that. Okay. But I do need to. Oh, I see. But that doesn't force. That's not this problem. The 10 has to do with the fact that I need um, data kinds, probably. And apparently kind signatures. Okay. Neat. That's pretty cool. This is going to be really hard for me. We're going to have to find a project to work on, I guess, at some point for this. Oh, oops. We can try. I'm into it. So we need this. We need this. We need that. And then we'll get rid of this. Yeah, it basically just doesn't do anything. It doesn't evaluate it. Just more or less prints back what you had. So, okay. That's interesting. So I just noticed there's like 8 people watching, so hello. How's everyone's evening doing? Um I'm probably gonna get off relatively shortly, within a half hour or so. But I am glad to be back because it's been a little while. We're doing some type level programming, and it's hard, not surprisingly. But luckily, TypeRat's here to help us. What's going on, Oren? Glad to see you here. How was your week off from my terrible programming? Good. Good to hear. It's programming is so hard. It's so hard. Anyone that tells me it's easy just think they're monsters. Okay. Actually, I turned the page because I was looking for an example, but we're technically not done yet. Me three, nice. So this is the realm of terrible programming. I'm glad you're all here. We can program terribly together. I wouldn't have it any other way. So what is it? A to exp b, a to exp c. Oren, can you hear my new keyboard? I'm pretty happy about it. It's been pretty fun so far. So F G X eval. Oh, that's fun. F eval G X. Then fixer. I need to review all the rules for it's mechanical, yes. I'm liking it so far. It feels good. But TypeDrat showed us some really cool keys. So I kind of want to go get better keys because my my command key, or what would be a Windows key, is like the Mac command key right now. So it's it's not. It would be much nicer if it had like a little Linux symbol on it or something. Okay. So anyway, the point is this behaves like function application. Behaves like composition at the type level. With the Mac ones. Like the new Mac laptop keyboard? Is that what you're talking about? Because if you are, I'm worried about you. I really can't deal with those keyboards. I typed on one for like a few minutes and I was just like, I don't get it. Need to press buttons. Oh, well. Yeah, okay. Oh, okay. The one before 2016. Okay. Yeah, those keyboards were okay. Those keyboards were fine. I like the keyboard on my Oryx Pro as well. It's pretty nice, but I think if I play around with this more, I'm gonna quickly realize that I like it quite a bit. What was I doing? Oh, I wanted to evaluate, or just look at the evaluation of this because it looks kind of crazy. So we're gonna make. I can type faster on them with nail extensions than even my fancy mechanical ones. Oh, uh, uh, I get you. Nail extension. I've never typed that way, so I don't know how that works. All right. So we're going to compose these things. Yeah, I mean, that's important. However you can type the fastest, that's the most important thing. Second to, okay. So, I've never actually tested my typing speed, I don't think. I shouldn't do it on this keyboard today, that's for sure, but not on a keyboard I feel comfortable with. All right. So kind eval we're taking second. One. We should get 3, I guess. Well. Yeah, let me read this more carefully. Oh, that's true. So this one, the other eval comes from my first instantiation of it. More thinking, less typing. That's funny. Oh, wait. Yeah, the other eval just comes from my lib. So it can't tell the difference in this. Yeah, this one. It is what it is. It's not that big of a deal. I just have to remember to do it. Now, the real question is, why doesn't it work? Supposedly this should work. There's something to do with... Oh, we can do that. Oh, okay. Interesting. So somehow we, by importing and setting stuff, we've... Something about the language extensions. Yes, yeah. Something about the language extensions wasn't able to properly turn this type in the right shape, I guess. Or it didn't have the right kind. Is that correct? Yeah. It didn't have the right kind. Okay. Interesting. That's really cool. Okay, and then we should do it without polykines, essentially. Just to see what it ends up looking like. Yeah. So, something about this. Oh, interesting. I never knew that. Thank you. I should write that down somewhere. No one has ever told me that. That's really useful. Although I guess I don't spend a ton of time in the. Mhm. Yeah, I don't spend a lot of time programming in the REPL, so we only use it to test stuff. But that's really useful. So. Oops. Now, actually, hang on, I want to try something. So set this, define it, turn it off, and then look at the kind. Okay, so it still stays the same, even like because the extension is on when you're it's not compiled, it's interpreted, I guess, in this case. When it's interpreted with polykind's on, it retains the kind. So you have to define it without the. Okay, this makes more sense. Anyway, interesting. Leads to weird stuff. I'm sure it would. A lot of bad stuff. Okay, so we need. Sorry, I shouldn't have turned that off. Or I don't know if does that. If I reload, it probably stays on. But anyway, so this is what we need to write. We're gonna write something interesting, like longer, just so we can see it. So we're going to compose second with from maybe. And then we're going to apply it to oh, I put this parenthesis in the wrong place. Right, 1, 2, 3, yeah. Okay, so we're composing these functions together and then applying them to this. So we should get a 2. I think we're gonna get 2. And we need to fix the FCF thing. Yeah, neat. This stuff is really cool. I would like to I need to find a project where I can actually use this kind of stuff, because it would be really helpful. All right, let's go back in here. Yeah, it seems like you could do all kinds of interesting stuff. I just need to find a good reason to use it. I don't know how to come up with that. Okay, so there is apparently a first class families package, and provides most of. I wouldn't suggest writing a type level instruction decoder for a Game Boy emulator. That sounds interesting. Is that on GitHub or something? Or is it just like personal stuff, which is fine? Oh, I never finished it. Is that why I shouldn't try it? Intractable. Fair enough. Okay, so there's apparently a package where you can get a lot of this stuff. So for example, we can determine if any two types are the same. There is no eq at the type level. Okay. Whoops. Okay. So this one is an open type family, and this one's a closed type family? Is that the right terminology? Is it the combination of these two things that makes it an open type family, or just this piece? So eval is the open type family, and this is a closed type family. Yes? Maybe? If that's correct. Do you know the big difference with closed type families other than closedness? Yeah, no, I don't really remember the difference. I can go look it up. I'm just trying to. Let me go look it up because I do need to remember this stuff. Um we did talk about it at some point. I think that. So the problem with what me doing this, by the way, is that I can remember it for a little while, but then I immediately forget it. And so that's not really helpful. I really need a lot of practice to follow this stuff. But I can't find the text on closed type family. Um, so. That's okay. It doesn't look like I. Oh, I'm not actually logged into Twitch. I'm just doing it on. It depends which message you're talking about. I got. Do you know the big difference with closed type families other than closedness? And then, sorry, my stream died. So if you wrote something in the middle of that, I did not get it. But it doesn't look like I've dropped any frames, so I think it was on your end, unfortunately. So 36. If you sent me a private message, I can go look at it. That's fine. Okay. Okay. So let me read this. So this needs closed type families because otherwise tyek AB and tyek AA would lack apartness and therefore be rejected because there's a substitution where tyek AB and tyek AA are equal. I don't recognize that one symbol, but closed type families have ordering between the instances like normal function pattern matching does. That's okay. Okay, so okay, but this is a closed type family. It just means substitute B with A. Okay, so so let me write that in here because that's actually really useful. So tyek AB I'm gonna take your words. Sort of. Oops. Oh no, the terminology is fine. I think it's the right terminology. Um, Easy enough for me to read. But yes, academics do tend to write a little funnier, I suppose. I'm not very good at writing like an academic, unfortunately. Um, we'll just write this. Does that sound about right? You know, I like the terminology for sure. So, and then the other thing is the eval itself is the open type family, right? Like this isn't, this is, or is this? This is not an open type family. That is just a type system, or a type synonym, excuse me. Yes. Correct. Great. Oh, yeah, it's not even a type synonym. It's just a data type. Yep. Okay, and then this is a instantiation of the open type family eval. Okay. I feel more comfortable about the terminology anyway. So like looking at the shapes is helpful. Cool. Thank you. A lot. Okay, we gotta go back to where we were though. Here. Okay, let me write this and hopefully reading it in the book is a little hard for me sometimes. The code anyway. And I can't really explain it very well if I don't just show it to you. Oh, Type have you worked on this book? Or do you just kind of learn this on your own? Impressive. Oops. How long have you been writing Haskell? A. I don't really know what this means. 2014? Okay. So 5 years or so? All right. So that's what I got to look forward to. In 5 years, I'm going to be as good as you are. In theory. I hope so. Oh, well. Oh, this needs to be collapse. You learned it in high school? I assume that wasn't part of the curriculum. You were just learning, or did you actually have teachers teaching you? Just out of curiosity. You don't have to answer, obviously. I'm just asking because it's interesting. Just big nerd. Nothing wrong with that. Me too. Okay. So what is this doing? I don't quite understand what it's doing. That sounds fun. I wouldn't have done that in high school, but that was because I was completely I didn't talk to anyone in high school. I was just a shut in who played WoW all the time. So I was a different kind of nerd, but also a nerd. I never got into clubs. I ran. That's all I did. Um I don't understand what this is doing. So we're just creating a tuple of the constraints. So this is like the point of this. Where would I use this? So like it looks like a function that's taking a list of things and converting it to a tuple, but I don't understand the point. Like, where am I using this? Maybe there's more text about this. Well, okay, let's write these, and then maybe it'll become obvious. Give me just a second. You might not have to type what you're typing, but we'll see. Oops. I can't type all of a sudden. It's pure one. Oh, okay. My typing is going down the drain very quickly. Give me a second. I have no idea what I'm doing here. Okay, so we're creating an F map of sorts. Why is this pure one? Oh, I see. Okay. It's pure with. Okay, let me read this. Constraint Ike num a show A to A. Oh my goodness. Gain. Oh, I see. Okay, I got it. I got it. It's equivalent to that tilde is not like the tilde from uh it's not actual tilde in Haskell code, I don't think. Sorry, it took me a minute to get that. So this is like pure, but with I don't know if there's a analogy here. Yeah. That's okay. It just took me a second because I was like, um, I was thinking that it was not metaphorical. All right, trying to understand this. Yeah, I understand what it's doing, but the name is throwing me off. But like I wouldn't. The name pure is throwing. Okay, as long as we agree it's a bad name, then I'm fine. I'm fine with it. All right, so C takes a K and computes a constraint. And we have a list of Ks. We want to turn those to constraints and then collapse them. Could we see an example? Yes, we can. Luckily. It'll help me sleep tonight. FCF val all equal I wish there was a second example, but we can make one. Okay, this isn't doing what I thought it was doing. I don't immediately see what this is for. Like when, I think I see what it's doing now, but I don't know when I need this. Okay, well, that's fine. It's interesting. Like it looks cool what it's doing, I think, but I'm having a hard time visualizing when I would actually use it. So okay, as long as we're on the same page and we can move forward and not feel bad about it. 9:45. I think that we will stop, and the next thing we're going to talk about is ad hoc polymorphism. Yes. So we're going to talk about ad hoc polymorphism next Sunday. We're doing a little. We're going through these books a little more slowly than we were before because we're doing multiple things now. But I'm trying to do different things just to keep it interesting. So we're doing this thinking with type books on Sunday, and I would be happy if you came back and helped me next week. It's really nice of you. And on Tuesday, we do Book of Monads because we found a lot of cases in this book that we didn't feel very comfortable. For example, with continuations. So things like continuations. So we're doing Book of Monads as well. And then on Thursday, we're trying to exercise our practical Haskell. So that's us working through exorcism. So thanks to the new followers again, Meet Aman, Barano, Typed Rat, and Blue Laguna. Well, if you come by on Tuesdays, eventually we're going to get to that chapter. I read it this weekend, and I think that I almost understand it. I think working through the chapter in code, it might help. But I think we're close. When we did it in this book, and we were thinking about continuations, a lot of us had a lot of trouble. We've had conversations in our Discord about it being confusing, and I was like, I'm going to understand it, so I will hopefully be able to kind of explain it at some point. That's the goal. But that Book of Monads book is very good. I like it quite a bit. So